Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this lecture, we are going to see some definitions and terminology that are related to machine tools. So first of all, what is a machine tool? There are two types of machine tools which we are going to study in this topic. The first one is lathe machine. So lathe machine is a machine which is used to do different machining operations on any kind of metal pieces. A lathe machine is a machine that is used to remove unwanted material from a rotating workpiece in the forms of chips. And this is accomplished with the use of a tool that travels across the workpiece and feeds into it. So any lathe machine will remove the unwanted material from the metal piece by turning operation or any machining operation. So in this way, we can get the required shape out of any metal piece. So the lathe machine is very widely used in most of the mechanical engineering applications, and most of the metal parts will be turned or it will get the shape based on the work that is done on the lathe machine only. And then we have second type of machine, that is milling machine. So what is a milling machine? So unlike lathe machine, milling machine will accomplish multi-point cutting tool cuttings. So in lathe machine, we will have only a single point cutting tool. That means it can remove the material from a metal very slowly and at a rate which is very less than the milling machine. Whereas in milling machine, we will have multi-point cutting tool. That means it will have more than one cutting tool by which we can accomplish the chip removal from the metal at a higher rate when compared to lathe machine. So this is the basic difference between a lathe and a milling machine. Apart from that, all the processes or the machining operations can be done on lathe machine, also possible on milling machine. Only difference is lathe machine has a single point cutting tool, whereas the milling machine will have a multi-point cutting tool. And when we see the definition of the milling machine, it is the process of machining using a rotary cutter to remove the material by advancing the cutter into the workpiece. So in lathe machine, the workpiece will be in rotation, whereas in milling machine, the tool will be in rotation. So we will mostly deal with two parts. One is tool and the second one is workpiece. So workpiece is the metal plate or an object on which we want to get required shape. And tool is the metal object which is used to remove material from workpiece. So initially we will have some design into which we have to convert the workpiece, and we will process that design on any machine like lathe or milling machine. In lathe machine, the tool will be stationary and workpiece will be rotating in circular motion. Whereas in milling machine, the tool will be rotating and workpiece will be stationary. This is another difference, and this may be done by varying directions on one or several axes. So we can have multiple direction motions that are possible in the case of milling machine. Okay, in lathe machine, only two feeds, like two types of movements can be given. One is feed and second one is depth of cut. So which indicates two dimensions are possible. Two-dimensional motion is possible in the case of lathe machine, whereas in milling machine, we can give three-dimensional motions, which implies that we can remove the material in all the three dimensions of the metal piece or the workpiece. Now let us see what are the operating conditions of a lathe machine. And when we see this figure, in this figure we have a chuck, which is the work holding device. That means the workpiece will be inserted into this chuck. And then we have a cutting tool. This cutting tool is what responsible for removing the material from the workpiece. And we have different cutting speeds that are possible in lathe machine, because we can use the gearing mechanism to change the speed of the rotating workpiece. And then we can change two types of motions that are possible for the working tool. So they are depth, that is depth of cut, small d, and feed, which is represented with a small f. And then we can see the formation of chip. So the unwanted material which is removed from the workpiece is always called as chip. Okay. So here we have depth of cut and feed of cut. Two dimensional accuracy is possible in the case of a lathe machine. And let us see some of the operations that are possible on a lathe machine. The first operation is turning operation. So to remove the material from the outside diameter of a workpiece to obtain a finished surface. So turning operation is also a operation in which we have to remove the unwanted material, but removing the unwanted material or to decrease the diameter of this workpiece, that process is called turning process. So turning operation, for a cylindrical rod, we can reduce its diameter. So initially the diameter of the rod may be 10 mm. Now after finishing, after doing the turning operation in lathe machine, I can reduce the diameter to some 8 mm depending on the design. So that is turning operation. And then we have facing operation. So facing operation is used to produce a flat surface of the workpiece or for making face grooves. Suppose if this is a workpiece, which is a cylindrical workpiece. So when we are talking about a lathe machine, we mostly deal with cylindrical objects because it is easy to machine these type of shapes. Only cylindrical shapes are possible on lathe machine. Even though if you want to do multiple shapes which are near to cylindrical shapes like hexagonal shape or some other shapes which are very similar to the cylindrical shape, we can do operations on them also. So if we want to clean the surface or to increase the surface finish of this cross section, then we will do the facing operation. So we will keep the tool in such a manner so that it will remove the surface cross section area of the cylindrical rod will be cleaned or it will be smoothened. And then we have third operation, that is boring operation. So boring operation is a process which is used to enlarge the hole of a cylindrical cavity. Suppose in lathe machine, there is a cylindrical object just like this. It has a hole inside. It has a through hole. If we want to increase the diameter of this hole, we have to use the process called boring operation. Okay, boring operation will increase the diameter of the hole, and also it is used to increase the surface finish of the hole. Okay, we want to get a more smoother hole surface. So when we will go for boring operation. And then we have drilling operation. It will produce a hole on the workpiece. Simple, a drilling operation will produce a hole on the workpiece. So the hole produced by this drilling process may not be that much smooth. That is why we should go for other operations like boring operation, in which we can get smoother surface. And then we have reaming operation. So this is also used for finishing the holes which are produced in drilling process. But the drilling process will give you a hard finish surface of the hole. So in order to get a smoother finish, we have to go for reaming process. And then there is a threading process. So threading process is nothing but it is a process which is used to create external or internal threads on a cylindrical body. So if you want to lock two mechanical elements, we want to use some kind of nuts. Nuts and bolts will be used. So these nuts and bolts are manufactured with the help of this threading operation only. Initially, any thread will be cut on the outer diameter, on the outer surface of the cylindrical rod, which is called as a bolt, and internal threads will be cut on the nut. Okay, both nut and bolt will be screwed together to form a strong joint which will assemble two mechanical elements. And then we have a last operation, that is knurling operation. So what is knurling operation? So knurling is an operation. It is produced to a regularly shaped roughness on the workpiece will be created by doing this operation on the mechanical element. So if we want to hold any mechanical object, so if the surface is very smooth while holding, we may not have a good grip on the surface. So that is why we will give some knurling serrations on the surface so that it will be easy to handle and we can get a good grip on the metal surface. So these are some of the operations which can be performed on a lathe machine, and let us see each process in detail. So facing operation is used for reducing the surface finish, or to increase the surface finish of the cross section of the cylindrical rod. We will use this facing operation. So facing on the milling machine involves various milling operations, but primarily face milling can be done on lathe machine and also milling machine. So on lathe, face is commonly used in turning and boring operations. Okay, in these both operations we can do facing. Other preparations remove material in ways similar to facing. For example, planing, shaping and grinding. So these are some of the other processes other than lathe and milling where we can do facing operation. So in a planing machine, shaping machine as well as in grinding machine, we can get this facing operation to be done so that we can make the cross section of a cylindrical or any object smooth. Okay, we can increase the surface finish of the cross section. So by using not only lathe and milling machine, we can use other machines like planing, shaping and grinding machines. So mostly it is not labeled by them as facing. So if we do facing operation in these machines like plating, shaping and grinding machines, they are no longer called as facing. They have their own names. And then we have boring operation. So boring is the process of increasing the diameter of a pre-existing hole. Suppose a metal object has a hole in it. So if you want to increase the diameter of the hole, we should never go for drilling because the hole is already there. We don't have to create a larger hole with the help of a drill. We should use a boring tool to increase the diameter of the pre-existing hole. So in order to increase the diameter, we will use a special tool that is called as a steel carbide boring tool. So the tip of this tool is made up of carbide, which is very hard when compared to a normal steel or high-speed steel. So this type of tool, you can see in this picture, the tip of the tool is very shown in a dark color, which is indicating that it is made up of carbide. So carbide, when it is combined with steel, it will form a very strong material, like it can cut all other metals. Okay, so this type of tool is used for increasing the diameter of the hole that is already existed in the workpiece. Not only increasing the diameter, we can actually increase the surface finish of the workpiece also. We can increase the surface finish of the hole. Okay. So boring is used to achieve greater accuracy of the diameter of a hole because we will get a rough hole while drilling. That is why we have to get more accurate holes with the help of boring process. And then drilling. So we already studied that drilling is a process which is used to make holes in a workpiece. So the tools used for making holes or to do the drilling operation are called as drill bits. And the machines which are used for this process are called drilling machines. So from this we can understand that the drilling is a process which make holes into workpieces, and it also do hole making operation is the most important operations in the manufacturing, and drilling is the commonly used process for this. So drill bits and drilling machine. So this is the terminology that is related to any drilling operation. And then we have another process called reaming process. So reaming is an operation used to make the existing hole dimensionally more accurate than drilling. So the primary purpose of a reaming process is to increase the dimensional accuracy. What is dimensional accuracy? So why do we need this dimensional accuracy? Let us see. So if I have a drill bit which is rated as 5.00 millimeters of diameter. So I can make a hole of this diameter by using a drill bit. So it is rated as 5 mm. Actually, the diameter of the diameter of the drill bit is not actually 5 mm. It should be less than that. Why? Because after making the hole on the workpiece, we have to remove it from the workpiece simply, which means the drill bit will be rotating at a higher speed. While rotating at high speed, it will remove some chipping material. So while chipping material is removed through the shank of the drill bit, we have to make sure that there should be some dimensional feasibility. That means the hole that is produced by the drilling bit should be more than the actual dimension of the drill bit. Okay. So for this, we don't need to use other techniques. We simply decrease the actual dimension or diameter of the drill bit. So I will take a drill bit of dimension 4.90 mm. So even though the drill bit is rated as 5 mm, its actual dimension will be 4.90 mm. So I have given a value that is of about plus or minus 0.10 mm. So this dimensional accuracy is given in order to facilitate more dimensional accurately preparation. So 4.90 is the actual dimension. Why we are giving this is a drill bit which is of diameter 4.90 will produce a hole of about 4.95 mm diameter hole. But actually I need a hole of 5 mm. So what I will do? I will go for other operations because most of the drill bits, for the safety purpose, they will be producing a lesser dimension hole. Okay, just only small variation will be there, but they will produce a smaller hole as required. So that is why we should go for other operations, not only for the safety. Once the material is removed, we cannot get back. Once the metal is removed as chip, it cannot be put back. Okay, so that is why we have to be always cautious in order to remove the metal from the material. Okay, so we will produce a 4.95 mm diameter hole, and after this I will use other operations like reaming or boring in order to increase the dimensional accuracy. I will ream this plate, this hole, to 5 mm diameter. Okay, so to increase the diameter or to improve the dimensional accuracy and surface finish, I will use the process called reaming. So most accurate holes are produced by the following sequence of operations. First of all, we will do centering. We will position the center of the hole where we will put a small dot with the help of a dot punch. And after that, we will use drilling machine to make holes. And after that, we will bore the hole in order to increase its diameter. And after that, I will use reaming process to improve the surface finish and to improve the dimensional accuracy of the workpiece. And then we have cutting screw threads. So what is a cutting screw thread? So there are different types of tools which are used for cutting screw threads. The screw threads might be internal or external. Suppose if I have a nut and bolt arrangement, this is a bolt and this is a nut. So on the outer surface, I should have some threads in order to make it possible to be driven into a nut. Whereas in the nut, I have internal threads. So when we want to cut these threads, these are initially cylindrical and cylindrical. Both of them are cylindrical in shape, but we have to create these threads on the internal surface and our external surface. So this is nut and this is bolt. So we have to create external threads on the bolt and internal threads on the nut. So in order to do this, we have to use some special tools. These tools are like these are made up of helical or spiral path. So the process is called screw thread cutting. So the screw thread cutting can be done on lathe machine as well as milling machine. Okay. Nowadays, most of the plumbing supplies and gas pipelines may require this type of external and internal threadings. So these type of threadings are made in a tapered manner. So what is tapered means? Increasing or decreasing diameter threads will be made on the body. So in order to do this, we use the process called tapered thread cutting. So why do we need tapered thread cutting? For making them airtight. So if I use the pipes for like plumbing supply or gas pipes, I have to go for this tapered thread cutting so that it will produce a airtight joint at the threads. Okay, that is why we have to go for tapered thread cuts. Threads traditionally have been machined, but they are increasingly being formed by thread rolling process. So in the olden days, most of the thread cutting process will be done on the machining machines like lathe machine, milling machine, etc. But nowadays they are being produced by thread rolling process. So the thread rolling process is a process in which the threading will be made on the object itself before it is being forged. So we know rolling is a forging technique which is used to done at a higher temperature. That means the metal object will be heated near to the crystallization temperature and the body will be converted into different shapes. At this time only, we will cut the threads because a hard metal object is very easy to be manufactured, or it should be very easy to cut threads on a hard body. So that is why rather than cold working, we will go for hot working for thread cutting. So this is screw thread cutting. And then we have tapping process. So tapping process is the use of a tool which can drill internal threads. Okay, so internal threads can be easily given on a metal object by using this kind of tools. So they are called taps. So the process is called tapping process. So internal threads in workpieces can be produced by tapping process. A tap is a chip producing threading tool with multiple cutting teeth. They are available with 2, 3 or 4 flutes. You can see in this picture, this tapping tool has 4 sharp edges which are called as flutes. So 1, 2, 3. On the other side we have 4th cutting tool, cutting edge. So all these 4 flutes will work as thread cutting devices. So when this tapping tool is inserted into a hole and it is screwed tightly, we can see the formation of threads on the internal surface of the hole. So tapping is the process which is used to create threads on the internal surface of any metal plate. And next one is honing operation. So honing operation is an abrasive machining process that produces precision surface on a metal workpiece by scraping an abrasive grinding stone on the grinding wheel against a controlled path. So simply honing process is a surface finishing operation which might be used for external surface or internal surface like holes. So this is used for in this process we will use some honing stones as the tools. So these honing stones are made up of abrasive particles just like grinding wheel. So we all know grinding wheels are the machines which are used for improving the surface finish or to sharpen the tools. We will use this grinding operation. Similarly, the same kind of material which is being used in the grinding operation will be used for the making of these honing stones. So honing stones, they will remove very small amount of material from the metal. Inside the holes, we can do this honing operation, or outside a metal object also we can do honing in order to make the surface very smooth. So this honing process is mostly used in finishing of cylinders for internal combustion engines or air bearing spindles and gears. So wherever the precision is more important, at those points, those places we have to use this honing operation. And there are many types of horns, but all consist of one or more abrasive material. So under high pressure, they will act as a chipping removal devices. Okay, most of them contain abrasive particles. So that is all for this lecture. We have seen all the different terminology and definitions that are related to machine tools, and in that we have seen different processes and applications of lathe machine and different operations that can be performed on milling machines. So all the operations are possible on both the machines. So depending on the type and size of the body, we should choose a particular machine. So we'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.